very big thrust now in algorithms and a lot of areas of mathematics is the role of probability. You take a random graph and you say, what are the properties you expect of a random graph? Almost all of them have certain properties, and sometimes it was Shannon was kind of one of the early people. Almost all codes are pretty good, but now find me a good one. Well, anytime you have a very specific rule, that's so special, that's not a random one, and probably it's not very good. So the idea that you could find very special constructions so graphs behave like random graphs, but they're not random, we termed it quasi-random. And so it turns out that there are a few conditions on a graph that once it has these conditions, especially for families of graphs, then in fact it behaves very much like random graphs in many other ways. There's a whole equivalence class of conditions. So this is also kind of an active area to decide how much randomness you need locally before the whole thing behaves globally like a random object.
The idea of quasi-randomness or the probabilistic method in combinatorics seem like the kind of things that are so obvious now they should have been discovered earlier.
Right, like the safety pin, right, or the paperclip.
Right.
Why didn't I invent that? Right. Hindsight is great, and it's you never know. When you plant a seed, a little acorn, will it just turn into a weed, or will it be a great oak tree? You don't know.
It seems like combinatorics and discrete mathematics have had that happen a lot.
Well,
over your career.
Yeah, combinatorics is a relatively recent, has recently emerged and kind of a little more mainstream. And in the old days, graph theory was often called the slums of topology. And I would do it in he wrote about kind of the panorama of mathematics. In the French version, combinatorics was called breakfast mathematics. In the English version, it was pre-mainstream. But now it turns out that there's a more of a well-defined body of tools, the regularity lemma and the Graph-Minor's theorem, really substantial theorems, which can be applied in general situations. For example, Semiretti's regularity lemma now is a key part of the Green-Tau theorem that the primes have arbitrary long progressions. And people begin to understand and use some of these more powerful techniques. And of course, the computer is big. A computer is basically digital, and you got zeros and ones. Then you have integers, and if you have integers, you have number theory. And so it's really, it's a very natural thing to emerge. I wrote a book with Don Knuth and our TA, Orrin Potashnik, called Concrete Mathematics. And the word concrete came from continuous and discrete, the two words, to show that the interplay between the continuous and the discrete. So I think early on differential equations were continuous, and now the pendulum is swimming a little more toward the discrete end and the interplay back and forth. So I think when you get Fields medalists in discrete mathematics, combinatorics, that gives it a certain okayness, right? It's okay.